Breaking news, trebuchets are pretty cool. As you can see by this video, they throw an object by dropping a massive counterweight. The launch happens when all of the potential energy in this counterweight is transferred to kinetic energy of the counterweight, which then launches the projectile. Potential energy is the stored energy of any object. In order to gain a large potential energy, you'll need a counterweight with a large mass or a tall height. As you can see from this equation, either the height or the mass of the counterweight can directly affect the potential energy that you have. During the conversion, there will be some energy that is transferred to the air by air resistance and friction, meaning the kinetic energy will precisely equal the potential energy at the beginning. In order to launch the projectile far, it must have a much lower mass than the counterweight. There are some key factors you must consider that can make a mediocre trebuchet a dank trebuchet. First, you need a large area for the sling to pivot, because this will give the projectile a higher maximum velocity. You also need to make sure that your rope is long enough so that the projectile releases at an angle which will cause it to fly the farthest, but not so long that it loses tension during the launch. Finally, you'll want to add wheels to the trebuchet because these make it fire up to 20% farther. 3 last tips to consider while building a trebuchet are: 1. The initial release position should be such that the beam makes a 45-degree angle with the ground. 2. The length of the beam on the projectile side is 3.75 times the length of the beam on the counterweight side. And 3. The length of the sling is equal to the length of the beam on the projectile side. For the Channel 8 News Team, I'm Alec MacDonald.